Okay, in this video, we are going to study combining functions. So we're going to see how can we use two functions, fx and gx, and use them to create some other functions. So here is what we're given. We're given two functions, fx and gx, and we're given that the domain of each function is a and b. Now, if you forget about what is a domain, now domain is the set of all the possible inputs of the function. And here we can use fx and gx to create these four different functions. The sum of fx and gx, the difference of fx and gx, the product of fx and gx, and the quotient of fx and gx. Okay, now let me show them to you one by one. The sum of the function fx and gx, we use this notation, the parenthesis of f plus g to represent. And the definition of the function is it equals fx plus gx. And the domain of this function is the intersection of the domain of f and g. Okay? And the difference of fx and gx, we use this notation, the parenthesis of f minus g to represent. And the definition is this difference function is equal to fx minus gx. Now, if we're gonna to define the difference of gx and fx, in that case, the function is written into this. Now, so here, please keep in mind, the g minus f is just like a notation, just like the f or g we use to denote the function. And the definition here is gx, it equals gx minus fx. Okay? And the domain is the same, it's the intersection of the domains of fx and gx. And the product of f and g, we use this notation, the parenthesis of fg. And the definition is the product function equals fx times gx. And the domain is the same. Now the quotient function is given by f over g. And the definition is it equals fx over gx. Now for the quotient function, the domain is different. The domain is the intersection of a and b, and also we need to exclude any x that will make gx be 0, because if gx be 0, the denominator will be 0, so the whole thing will be undefined. Now, next, I'm gonna use some examples to show you how to create these functions using the given fx and the gx. Now, for example, here we're given that fx is a polynomial x squared minus 8x plus 4, and gx is another polynomial negative x minus 2. And we are looking for these four functions and also their domains. Now, the first step is we are going to determine the domain of each function. Now, because both fx and gx are polynomials, and we said if a function is a polynomial, then its domain will be every real number. So therefore, the domain of fx is every real number, and we usually use the interval notation from negative infinity to positive infinity to represent this. And the domain of gx is also every real number, because they're both polynomials. Okay, now we're going to create the sum of fx and gx. So this is equal to fx plus gx, which is equal to because fx is x squared minus 8x plus 4, and plus negative x minus 2. Okay, then you will need to simplify this expression. So then I have a minus x minus 2, and if we combine the negative x with the negative x, we are going to have negative minus 9x, and we combine 4 with the negative 2, we're going to have positive 2. So x squared minus 9x plus 2 is the sum of fx and the gx. So this function is defined by this. It's defined by this equation. And the domain is the intersection of these two, which will be itself. So the domain is every real number. Okay. Now let's take a look at the difference of these two functions. Now this is equal to fx minus gx. So it will be x squared minus 8x plus 4 minus negative x minus 2. Now, please be careful when you are looking for the difference, because since we are involved a negative sign, so make sure, remember to change the sign after you remove the parentheses. Now, after we remove the parentheses, minus negative x becomes plus x, and minus negative 2 becomes plus 2. So then, after we combine the like terms, we are going to have x squared. Now, negative 8x plus x, we have a minus 7x, and a 4 plus 2, we have a 6. So the difference function of fx and gx is defined by x squared minus 7x plus 6, and the domain is from negative infinity to positive infinity, because the domain of the sum and the difference and the product, they are the same. So once you find the domain of the sum, you can use it as the domain of the difference and as the domain of the product. Okay. So next, I'm looking for the product function, which is equal to fx times gx. So to find the product function in this example, what we need to do is to multiply these two polynomials. Okay, so first we distribute x squared into negative x minus 2. We're going to have x squared times negative x minus 2, and plus we distribute negative 8 into minus x minus 2. So we're going to have this term, and then we distribute 4. And then next, so x squared times negative x, this is negative x to the third. X squared times negative 2, this is negative 2x squared. Now negative 8x times negative x, that is positive x squared. Negative 8x times negative 2, that is positive 16x. And 4 times negative x is negative 4x. And 4 times negative 2, that's negative 8. And then if we combine the like terms, so negative x squared we combined with 8x squared, we're going to have 6x squared. And 16x minus 4, we're going to have 12x and minus 8. Therefore, the product of fx and gx is this, and the domain is the same from the negative infinity to positive infinity. Okay, now let me do the quotient function. The quotient function is equal to fx over gx, which is x squared minus 8x plus 4 over negative x minus 2. And when we are looking for the domain of the quotient function, remember, according to the definition, we have to exclude anything that will make the denominator be 0. We have to exclude them from the domain. So if we think about which numbers are going to make the denominator of this function be 0, the answer is going to be negative 2. In other words, to think this question is like you think about what is the solution of this. So the answer is x equals negative 2. So therefore, when we are considering the domain of this function, the domain should be every real number except negative 2. And we can use a set to write this. So the domain will be anything except negative 2. Or if we use interval notation to express this, so it's from negative infinity to negative 2. Now remember, here we use parentheses, so that means the negative 2 is not included. And from negative 2 to positive infinity. Okay. So this is the only difference when you are looking for the domain. Okay. The domain of the first three functions are the same. But when you consider the domain of the quotient function, you have to consider the numbers that will make gx be 0. Okay.